Hello everyone. I welcome you all in the next lecture of 12th NCERT Mathematics. In this lecture, I'll discuss question number 14 of exercise 1.1. So let's start the question. See here. Let L be the set of all lines in the xy plane. Okay. So we have an xy plane. Okay. This is our x-axis. This is our y-axis. So collection of all the lines. This line, this line, this line. Any type of line. Okay. Collection of all these lines. Okay. In a Cartesian plane or xy plane, both are same thing. Now let R be the relation in L. It is defined. How it is defined? L1 comma L2 belongs to R. This L1 comma L2 belongs to R if L1 is parallel to L2. If L1 is parallel to L2, it means one line is parallel to the other line. Then we can say that belongs to R. Okay. That okay. We need to prove show that the R is an equivalence relation. Show that R is an equivalence relation. We need to prove in this question. Again, in this question, observe it has two part. This is first A part, and this is B part. This is our B part. Find the set of all lines related to the line y equal to 2x plus 4. Seen continuously 13, 14 and 12 also, we need to find, we need to show that is an equivalence relation. After showing the equivalence relation, we need to find the class of that element also, given element also. Okay. So in board exam, it is guaranteed that if the question come in 5 marks, then they will ask to show equivalence relation as well as they will ask to find the equivalence class. Okay. Now, let's start our solution. First of all, I'll do A part. So, L. L is the set of all lines in XY plane. Okay, collection of all the lines in XY plane. And what is relation R? Relation R, actually here is this is our A. Okay, if you are familiar with A, very good. If you are not familiar with L, then you can use A also. Okay, it's your choice, but first of all you need to assume let A equal to this thing. Okay, now R equals to L1 comma L2 such that L1 is parallel to L2. Okay, L1 is parallel to L2. One thing I will remind here, recall L1 and L2 are parallel if and only if L1 and L2 have same slope. Okay, if L1 and L2 have same slope, then we can say two lines are parallel. This thing you already know. Okay, if the lines, if we know na, recall the results. This is first result. We need to recall here. L1, if L1 parallel to L2, okay, if and only if, in other sense you can write, if M1 is the slope of the L1 line and M2 is the slope of the second line, then M1 equal to M2 if lines are parallel, and if L1 is perpendicular to L2, if and only if, what we have, M1 into M2 equals to minus 1. These two things we have, but there is no use of this one. Okay, we need to use only this thing. Okay, now for reflexive, as we need to prove equivalence relation, so we need to prove reflexive, symmetric and transitive. For reflexive, what we have, let small we can use small l belongs to capital L, be any line. Okay, so observe that as every line is parallel to itself. As every line is parallel to itself, it implies that L comma L belongs to relation R. So every element of L related to itself from first and second R is reflexive on L. Okay. Now for symmetric, let L1 comma L2 belongs to L, and also one thing we need to assume, L1 comma L2 ordered pair L comma L2 and L1 comma L2 belongs to relation R. If L1 comma L2 belongs to R, what it implies? L1 is parallel to L2. So also L2 is parallel to L1. Okay. Hence, what it implies? L2 comma L1 belongs to relation R. It implies R is symmetric on L. Okay. Now symmetry complete. Now transitivity. For transitive. For transitive means let L1, L2 and L3 belong to set L, and one more thing with one more thing we need to assume. What we need to assume? With L1 comma L2 belongs to relation R, and L2 comma L3 also belongs to relation R. Okay. If L1 comma L2 belongs to R, it means L1 is parallel to L2. Okay. And if L2 comma L3 belongs to R, it means L2 is parallel to L3. Okay. Now you observe that, suppose this is one line L1 and it is parallel to L2, and L2 is further parallel to L3, then you can observe L1 and L3 are also parallel, na? So we can imply that L1 is parallel to L3 from both. Okay. So implies L1 comma L3 belongs to relation R. Okay. And it implies R is transitive on A. On L, sorry. On L. Actually, I'm used to with the A, na, that's why. R is transitive on L. Done. It implies R is an equivalence relation. Done. On L. Okay. Now what we need to find? See here. Next thing is find the set of all lines related to the line y equal to 2x plus 4. Okay. Recall these things. L1 is parallel to L2, then their slopes are equal. Okay. B part. What we have a line? Line is L is y equals to 2x plus 4, and what we need to find? We need to find actually class of L. Okay, class of L we need to find here. Okay, now class of L means, class of L means, I will assume it is L1. Okay, for simplicity, L1, not L1. Yeah, L1 you can assume L1. So it is L, sorry, L belongs to capital L. It's the collection of all those lines such that L is parallel with L1. Okay, recall, if L is parallel to L1, what I need to write here? L belongs to L. L and L1 have same slope. If they have same slope, the slope of, now listen, L1 is of the form y equals to 2x plus 4, implies slope of line L1 equals to 2. Why so? Because here recall, if we have a equation of line y equals to mx plus c, then m will gives the slope of the line and c will give the y-intercept. Okay, where it cut the y-axis. So here that means L belongs to L, slope of L has to be 2. And how, what the format of that line? Y equals to 2x plus c, okay, 2x plus c, where c belongs to real number. Okay, and that is the class of L1. That is the class of L1. You change the c, all of the lines slopes are same, but if you change in the c, the line will change. Okay, and hence we have infinite lines, and hence we have infinite element in the class of L1. Okay, so I hope you understand this question. If you have any doubt, then you can do comments. I will resolve your query. Thank you for watching.